are moving on to page 10. Oops. Page 10 of our yellow practice packet for our Algebra EOC. And on page 10, number 9 says, write the inequality that represents the graph below. So our inequality, I'm going to think of like an equation, first of all, like y equals mx plus b. Y equals mx plus b. But instead of having an equals, we could have an inequality. We could have y is less than, y is greater than, y is less than or equal to, y is greater than or equal to. And I can see that we have a dotted line, so it's going to be one of these two. These are the inequalities that get the dotted line. These inequalities get a solid line because they include the line. These get a dotted line because the line is not included, only the shaded part is included in the inequality. So, and it's shaded above the line, right? It's everything on top of the line is what's shaded. So this is going to be a y is greater than equation. And for me to finish up my equation, I need two things. I need my slope, and I need my y-intercept. And I can see from looking at the graph that the y-intercept is at -2. I can see that my slope is negative because the bunny is going down the mountain. And I can just look at another point and look at that right there. We're in the corner every single time on here. So our slope, we're going down 1 over 1. So our slope is -1. So when we put that in, you could say -1x for your slope, but nobody does that. The 1 turns to Sneaky Ninja goes invisible mode, and we just say -x. And then tag on your y-intercept, -2, and we have created an inequality that represents the given graph. We practiced this in class with lesson N9W, and I didn't find anything else that looked exactly like this. That was a good one. So if you think you need a little more practice on this, then I would take my SMART score from an 80 to 100, or just do a couple more practice questions on this before your exam. So let's move on to number 10. Solve the equation -3 times the absolute value of the sum of 4x and 2 equals to -6. So we are solving absolute value equation here. And when I'm starting this, I am going to treat my absolute value like it's parentheses for a little minute here till I get them by themselves. So I'm just going to treat that kind of like parentheses, and and try to isolate this. So my first step, I want to divide both sides of my inequality of my equation by -3. And when I do this, it's going to make my -3's cancel out here. So I'm going to be left with my 4x plus 2, absolute value of that, equals to a negative divided by a negative is a positive, and 6 divided by 3 is 2. And now this is where solving an absolute value equation is different than solving a regular equation. Here's the rule, right? Absolute value 4x plus 2 equals 2. We're going to split this off into two equations. 4x plus 2 equals 2, and 4x plus 2 equals -2. Now we can solve them both for x. So I'm first going to subtract my 2 on both sides of my equals to give me 4x equals 0. Divide both sides by 4. To make the 4's cancel out, we get x equals 0. Or, over here, solving for x, I want to get rid of the 2, so subtract 2 on both sides of the equal sign gives us 4x equals -4. -2 minus 2 is -4. Divide both sides by 4 to make the 4's cancel gives us x equals a negative divided by a positive is a negative. 4 divided by 4 is 1, or x equals -1. So our solution to this absolute value equation has two answers, two x values. And in class, we did lesson 9LF. And that was the only lesson I saw that was really just like this. If you want to pick anything else to match this, you can go to your IXL learning plan for our Algebra 1 best standards and find absolute value practice. And that's this one right here, 9LF. Write absolute value equations from graphs, BXF. Complete a function table, absolute value functions, absolute value, and is there anything else besides this little section right here? Complete a function table, absolute value functions, I think that was the same one from up above, and transformations of absolute value functions, translations, and reflections. There's one more here, 9TC. All right. Let's move on to question 11. If you deposit $350 in an account that earns simple interest at an annual rate of 6.5%, if no other deposits or withdrawals were made, what is the total amount of money in the account at the end of 10 years? Right here, did I ever just put the Algebra 1 practice test? Old FSA. I never put the reference sheet. Florida Algebra 1 EOC, best EOC reference sheet. Beautiful. Best Algebra 1 EOC math reference sheet. I'm thinking about the reference sheet right now because as soon as I saw my keywords here, simple interest, I wanted to look here. Final amounts under simple interest. Simple interest. So the final amount, A, under simple interest is where the principal is multiplied by the rate times time, or multiplied by 1 plus the rate times time. So just so you know where I'm getting my formula from, it's right here on the reference sheet. And you deposit $350. That is your principal balance. So I'm going to highlight that green like I highlighted over there. That's our principal. That's our initial deposit is a principal. And our rate, I picked blue for rate, is 6.5%. And what is it worth after 10 years? Time, 10 years, I did pink. So, first I'm going to write the formula from the reference sheet. A equals P times 1 plus RT. And our amount, that's going to be our answer, equals the principal, 350, times 1 plus our interest rate, which is 6.5%. So I need to convert that to a decimal. 6.5%. To make it a decimal, I just divide by 100. You can do that on the calculator. It's 0.065. 0.065 times our time is 10 years. So now on the calculator, right, I'm going to solve to find the amounts. And I got to use my order of operations. So first, it's inside the parentheses. I got to multiply this. 350 times 1 plus. When you multiply that, we get 0.65. And then you multiply 350 times 1.65. When you add that, it turns to 1.65. And on the calculator, we're going to get The value of that account is $577.50. And now you can practice this more on your IXL. This was lesson Q8G. Q8G. And some classes we did this question. I think some classes we might have skipped it. So if you haven't done that yet, this is some practice that looks very similar to this, where you're working with simple interest. And make sure that you know where to find that formula on your reference sheets. And when you see those keywords, simple interest, you know to look at your reference sheet. Or if you see compound interest, you know to look right next to that on the reference sheet. And then last question on this page is number 12. You and your friend go to a store where all the shirts cost the same amount and all the pants cost the same amount. You buy 4 shirts and 5 pairs of pants for $150. Your friend buys 3 shirts and 3 pairs of pants for $100. What is the cost for each shirt and each pair of pants? So I'm right away going to highlight my keywords. So I go to the store, and I buy 4 shirts and 5 pants, and my total is $150. So that's me, you. That sentence. 4 shirts plus you bought 5 pants, and your total is $150, right? Is the equal sign. So 4S plus 5P equals $150. And then your friend buys 3 shirts and 3 pants, and your friend's total is $100. So friend buys 3 shirts plus 3 pants and spends $100. For me to solve this one, I'm thinking I could do substitution, elimination, or I could graph this. 4 and 3, I know my multiples of those. 4 times 3 is 12. I can multiply those equations pretty quickly. I think I want to go the elimination method. So what we're doing here to find the cost of each shirt and each pair of pants, cost for each shirt and each pair of pants, right? We're going to solve this system of equations. So our solution shirts cost some amount of money, and pants cost some amount of money. And now to solve here, yeah, I think I want to multiply all of this, both sides of the equal sign, times 3. And this bottom one, I'm going to multiply both sides of my equal sign times -4. And I'll write that right underneath here. So 3 times 4s is 12s. Positive times positive. 3 times 5 is 15p equals 150 times 3 is 450. And down the bottom, -4 times 3 is -12s. Negative times positive again. 4 times 3 minus 12p. -4 times positive 100, -400. Now I can combine these two. 12 minus 12s, they're going to eliminate. And then 15 minus 12, we're left with 3p. 450 minus 400 is 50. So I can find out real quick now how much each pair of pens costs by dividing both sides by 3. And I get each pair of pants costs 16.6 repeating, but we're talking about money. So the calculator says something like this. So my money, right, I've got to have my 16, and then I can put 2 numbers behind my decimal. So I'm going to round to the hundredths place. And my thousands place back here, this 6 tells this 6, 5 or more, you go up one more. 16.67 is my cost. Oh, that's my cost for pants. 16 and 67 cents, because that was P. And now we can take our value for P and plug it into our equation and find out how much the shirts cost. So actually, I want to look back at my original equation. So I'm going to erase this work here. Goodbye, blue. And if I erase this as well, I kind of see a shortcut. I see right now that I have 3p equals 50, and there's a 3p right here. So I can substitute this in for here, and I think it'll save me a little pinch of time. So I'm going to use my friend's equation and say 3s plus, instead of 3p, I'm just going to write 50 equals 100. And now I can solve for S to find out how much each shirt costs. So take away 50 on both sides of my equation. Leave me with 3s equals 50. Oh, look at that. Pants and shirts cost the same amount. Divide both sides by 3. Each shirt costs 16, and then this is going to keep going on, and we're going to round just like we did for the pants, the same value, round to the hundredths place, thousandths place, tells the 6 to go up by one more, 16 and 67 cents. And to practice this on IXL, it is lesson US 9. And we are finished with page 10. I'll see you on the next video. Good luck, Cobra.